Hello everyone. This video is still about parking, reversing parking, but the key problem this video will show you is how to change vehicle routing based on the amount of pedestrians. So there is a script you can just use in any model you have if you follow the principles I show you. This is only just one solution. There are other solutions as well, but in this one I use script. What you need to do, or what the model is here, you can see that there are 4 areas. It uses the assumptions and the principles from the previous models. So the first is 1 and matching up with the car park number, and then I go 5, 10, and 15 that also matches up the car park number. You can just go back and check those videos out to understand how to build these. But just to catch up again, it's quite important to name the static pedestrian routing. So 1 that goes from that to this area. This is the pedestrians the vehicle will pick up. And the number is the same, so as you can see it's 5, then it's 10, then it's 15. As you can see, for all parking lots there is a parking routing decision. It doesn't matter how you name these or number these and what settings you use. Just have a parking duration at least a few seconds, and besides that it will be fine. And the script will take over from the previous one. I still use the same scripts as I used in the previous models. You can see it here. So that the Zooks move passengers in it at first vehicle, so they all the same as previously. And what I have here is I have an area where I load pedestrians on, and then I distribute them into each area. And the vehicle will arrive to pick them up to the space where there are the highest number of pedestrians. If the same amount of pedestrians are there, the first one from the right, or the lower number, will be chosen. So the way I model it is, as mentioned before, I use a script, and in that script I manipulate this static routing decision. So for each, you can see there is 1 for each. So I number this as 99. So if I open it here, this is 99, 99, and this has 4 routing decisions, 4 vehicle routes. It is important that I name them with the same as previously. So the these are 1 and PUDO number 1, and this is gonna be the last one. This is 15, PUDO number 15, number 15, and the same goes for the static routing, the pedestrian static decisions. This is important because it makes it very easy to reference, because whenever you know that on this area you have the most number of pedestrians, you can just use the same number to just identify everything related to that. So let me show you how it works. So I load the vehicle in. You can see the number of people in it, or the occupancy. It goes away, it U-turns, then comes back, and then it's selected the first one because there you have the most number of pedestrians. 1 goes in, then it goes away with 2 persons. You can see here that is still the first one is the with the highest number of pedestrians, 2. There is 1 there, but the script keep having this one with the with the route. So if I go to the pedestrian and I select if I give the highest number of pedestrians now to this route, if we wait a little bit, then that pedestrian area will have the highest. So if we go back here, it will start picking up there. So now we have 3 there. So you can see the route now changed to that one. So this is 1. And there are now a lot of pedestrians. So now the vehicle will choose this route because this has 1 and the other has 0. And it makes the exchange there. So the way it works, as I created route select subroutine in route selector VBS. I load that in, I set it to simulation run and use the simulate at time step start. It is not that important, it can be at the end as well. Period, I just use 1 to keep it updated often. And this is the subroutine. So for the ones, so if you are a supporter on Patreon or a supporter on YouTube, you will have access to this to just download the code. If not, then this is the code. And so the way it works is I first define the variables, then I just set some default things here. So the default route will be 1. If there is no pedestrian anywhere, then the vehicle will go to 1. So you can, 1 is this 1, this is 1 area 1 and parking route number 1, and the same as for this route, it's 1. So if you want to change that, your default, just change the number here. As you know from previous videos, you can assign a reference. Basically, I call it a reference. I don't know what is the proper way, but you can basically put this whole thing into this variable. And then this section loops through every parking lot that is used for PUDO, this pick up and drop off. You can see that I get a filtered set of the car parks where the PUDO number is greater than 1. Go back to my old videos about these parking lots or pick up drop off videos. Then I explain in more detail, but basically we just have an attribute with PUDO for the car parks, and that is 1, here it is 5, so if it is more than 1, that it is used for PUDO. Then basically here I go through, I check in areas the occupancies. Not occupancies, the number of pedestrians. So I created a user-defined attribute to make our life much easier. As you can see, areas, number of pads, formula, and integer. If you just scroll down to pedestrian and you click count, so every time step, Vissim will count the number of pedestrians on each area. So when you click on this, you can place number of pads as a new attribute. And this will count the number of pedestrians in every step. So, in a variable, current pedestrian number, Vissim.net.areas item by key. So I select the area that has the identical number as the parking lot I am going through. So again, I go through every parking lot that is used for pick up drop off, and I take the number of that. So I take the number of this car park first, and I check the area with the same number, this number of pads here. and the attribute value number of beds. So area number 1 and the attribute value is number of pedestrians. If it's free, that number goes into this variable. And then I say if the number of pedestrians in that variable is more than the max pedestrian number, which I set an initial value of 0, then the maximum number of pedestrian is my current pedestrian number. So basically, if there is an area where there is a pedestrian on it, I check if that is greater than the current number in the maximum pedestrian number. At the first step, that is 0. But if, let's say, the second area that has a number of 5, if it has more pedestrian, that will override this. And I also say if the area number is that number. So if the first area has the highest number, then it's 1. If the fifth, then the fifth, or the area with number 10, then I put 10 here. So when this loop finishes, I have the area number and the max pedestrian number stored. The number of area will be stored in area number and the number of pedestrian will be stored in max pedestrian number. I store here the routing decision number of 99 because in my model I numbered this 99. Within this 99 I have 1, 5, 10, 15. Basically route for each location, yeah. Then the routing number is my area number. So as I said, this is why it's important to name everything accordingly. So 1 and 1. 1. So if then I go and say that if my maximum pedestrian number is more than 0, so that means after going through checking every area, there was no area where the number of pedestrian is greater than 0, then I set all route 0 besides the default one. So here, as you can see, Vissim.vehicle routing decision number, so the 99 routing decision number, and the route in it is the default route, that is 1. So this will be set to 1, all others will be set to 0. So as you can see, else, so if it is greater than 0, then it does this, but if it is 0, then it comes here and does this. So puts 1 into the default route, and this little loop puts 0 to all other routes. And so here I say that get a filtered set of all vehicle routes within 99, so all of these. It will go through all of these. And but the one that is not the default route. So basically default route is 1 and it gets all others but that. And then it puts 0 to those as it goes through, loops through for each static route. Static route is a variable, and in this filter collective. But if there was an area where you have at least one pedestrian, that means that the maximum pedestrian number is more than 0. So this condition is true. So it will undertake these steps. So the relative flow nu is 1. And basically I just put that into that route that corresponds to this area number where I have the highest pedestrian number. And so for each, I get all the vehicle routes, so these ones. And if this route is identical to my area number, then I put 1. I put 1. If not, so else, I put 0. So basically it loops through every single area, checks this number of paths. It keeps storing the highest one in a variable, and then the end, when it went through all, if let's say the third one with number 10 has the highest number, then it goes through here. It checks all of them and it puts 0 into all, but this one it put 1 here. So it will put 1 here and we put 0 to all. If there is no pedestrian at all in either of them, it will put 1 to the default one, which is the first. And it will go all the time to this one as long as a pedestrian arrives anywhere, and that makes the highest one. I hope it was helpful. If not, let me know in the comments and let's discuss what I missed. And if you want to support the channel, even just by liking and subscribing would help a lot, would promote my videos, the algorithm. And if you want to support me more, I would be grateful if you go to my Patreon and join as a member, a supporter, or you can just join in YouTube as a supporter, or you can just say super thanks, or the opportunity is there. Thanks a lot for watching and see you in the next one.